So the topic is traveling salesman problem, that is also known as the TSP problem. Before we start to the TSP problem, you have to recognize which field should be the applicable field for TSP. You can easily recognize that some of the traveling agency make their tour to a particular place and they visit every place exactly once and return to its home city. The way for finding the traveling salesman solution is that four different way you can use this traveling salesman problem. Those who are a rich person, they always need the lesser time, so the problem becomes a time problem. Those who are not financially strong, they always prefer to minimize their cost, then the problem becomes a minimum costing problem. So the problem may be the minimum time problem, maybe the minimum costing problem, whatever may be the problem desired to solve for this particular problem, for the particular desire of this problem. So we move to the topic. A salesman. Why it is called the traveling salesman? We just consider a salesman move from a city to another city, and after the end of the day he move he return to its home. So here we give a basic idea of the traveling salesman problem. A salesman has to visit in cities. He wishes to start a particular city, visit each city once and return to his starting city. The main object is to select the sequence in which the cities are visited. That means our main object, if we started from a particular city, if we want to touch the end city, the starting city is one city, that means he touch exactly n minus one city exactly once and return to its starting city. Our goal is to find which city should be the next city, preferable city, such that its time, or that if the problem is at the time should be lesser time, or if it's a costing problem, the cost should be the lesser cost. Clear? So here we give an example. For example, to visit two cities A and B, there is no choice. If you move from Kolkata to Delhi, then if you want to return Kolkata, it's a two city problem, just a move to Kolkata, nothing. So there is no choice from A to B, return to B to A. Okay. Next one is to visit three cities. We have factorial two possible returns. That means he just moved from A to B, B to C, C to A, A to C, C to B, B to A. That is two different possibility. So here we use the factorial two possible returns. For four cities problem, you can easily recognize just 4 minus 1, that is a factorial 3 possible returns. In general, to visit n cities, there are factorial n minus 1 possible returns, nothing more. Okay. So if it's a 5 city problem, the number of way you can find the solution is factorial 4. You have to choose the best solution or the optimal solution for this problem. So next one is to move the next page. Here he gives 5 city problem. Here he gives an example of 5 city graph or 5 city problem. City 1, 2, 3, 4 and 5. If you start from the city 1, you can move to city 2 or 3 or 4 or 5. Here we consider the two different color to recognize the solution of the problem. That is known as the feasible solution. The first solution is marked as black color. That is, you just move from 1 to 2, 2 to 4, 4 to 5, 5 to 3, 3 to 1. It's a complete tour. So it's a feasible solution. Another solution marked by the green color. You just move from 1 to 4, 4 to 3, 3 to 2, 2 to 5, 5 to 1. It's another feasible solution. That means if it's a 5 city problem, you can move from a city to any city. If the graph satisfies this, then you can find factorial 4. Factorial 4 means 24 number of feasible solution. You have to find the best feasible solution. Okay, because the fundamental theorem of linear programming says if it has a feasible solution, then it must have a basic feasible solution, and optimal solution should be a basic feasible solution. So our desire to find the best basic feasible solution, which should be the optimal solution. One observation is very important. So here we mention some note when we solve a TSP. The solution of any traveling salesman problem is a Hamiltonian circuit. That means if you draw a graph of the 5 city or 5 n city or any city problem, the graph, if you can move from a city to any city, the graph should be a complete graph. If a graph is a complete graph, then it must have a Hamiltonian circuit. The number of Hamiltonian circuit of a complete graph should be n minus 1 factorial. So the solution of any traveling salesman problem is a Hamiltonian circuit. If you reduce this problem to the graphical solution, because we have already learned in your second semester graph theory, you can find the shortest tree by Kruskal-Prim's Kruskal-Prim's Floyd algorithm. Another one is to find the shortest distance from a city to a particular city using Dijkstra method, but it's not mentioned that every city should touch exactly once. So the lesson desired to find the Hamiltonian circuit, that means you should touch every vertex exactly once and return to its the initial cities. If it's a 5 city problem, in the above example, if it's a 5 city problem, therefore the number of feasible solution is factorial 4. There is a two concept, one is called the subtour, another one is called the full tour. Full tour is nothing but a feasible solution, and subtour should not be a feasible solution. Now we give the mathematical formulation. The TSP means traveling salesman problem is a special type of assignment problem. So when you learn the formulation of a assignment problem, you can easily recognize the formulation of the transportation problem. Same as the assignment problem, we have already discussed in our previous few lectures the formulation tactics of assignment problem. Mean Z, Cij, Xij, summation over Cij, double summation over Cij, Xij, one for I, another one for J. So we use the double summation, and Xij from J equals to 1 to N equals to 1, where phi is the I is your choice. I is maybe 1, 2, 3, 4, 5, 6 and so on, and Xij, the second constant is Xij equals to 1. Xij is either 0 or 1. That is the basic formulation of a traveling salesman problem, which is nothing but formulation of the assignment problem. Here we can use Xij equals to 1 if the person I immediately from any person I immediately from I to J. If the person move from Kolkata to Delhi, then just we demarcate as X Kolkata to Delhi. If we represent Kolkata by K, Delhi by D, so the suffix should be XKD equals to 1. If the person not moved from Kolkata to Delhi directly before Delhi, the previous city is Kolkata, then we use XKD equals to 0, nothing more. That is the way of formulation of a traveling salesman problem. Here I give to recognize the subtour case. It's some example of the subtour case. This one, if we move from Xi to I, if it has a self loop, If it has a self loop, then xii equals to 1. If it hasn't any self loop, then it should be 0. Okay, clear? Another one is xij plus xji. That means you just move from a to b, I to j, and j to I. That the value should be less or equals to 1. Either you can move from I to j or you can move from j to I. You just consider only one case, so it's 1. If it's a 3 city case, you can move from I to j, j to k, k to I, and you can also move from xij to j to k, k to I, and so on. So the value should be less or equals to 2. Here we given a subtour of 2 city, 1 to 5, 5 to 1, that is less or equals to 1, 1 to 2, 2 to 4, 4 to 1, that is less or equals to 2. The total number of sub-tour, it's very important. Tour means the complete tour. If it's a 5 city problem, you can find a Hamiltonian circuit, it should be a complete tour. If you move, if it's a 5 city problem, you just move 2 city and return to your starting city, then it becomes a sub-tour problem. You can easily calculate how many number of sub-tour using this formula. NC2, if it's a NCT problem, n is an odd number, then the number of subtour can be calculated by NC2 plus NC3 plus dot 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 up to NC n minus 1 by 2. If it's a even city problem, that means the number of city is even number, that means 4, 6, 8, 10, 2 and so on. Then the number of subtour you can calculate. Number of subtour, again we repeat the term number of subtour. I am not mentioning the complete tour. Complete tour should be a subpart of the subtour, so the number of subtour should be NC2 plus NC3 plus NCn by 2, NCn by 2. This is a procedure we will discuss later. How can I evaluate a tour using this formula? You should not recognize initially from this, so we just not discuss this particular case. So we move to the example in the next lecture to find the solution of a transportation problem. Wait for the next lecture. How can I solve a TSP, traveling salesman problem, and how can I execute the solution using traveling salesman problem? Please watch and wait for the next lecture. Thank you.